Finally, we've reached the point where we're ready to launch some actual attacks. We're going to begin with attacks on WEP. Later, we will also look at other Wi-Fi security mechanisms and how we can launch attacks on those mechanisms as well. Just a reminder here, it might be illegal in various places. It probably is illegal in various places to be doing these things on a network where you don't have permission to be doing it. So don't do anything illegal. We begin with passive attacks where we are just listening, and even by just listening, we're able to figure out the key. Later, we will also look at active attacks where we can inject frames as well into the network. These can be helpful in situations, for example, where the network is idle and there's not much traffic that's going on inside the network. There are various possible attacks on WEP. We begin by a passive attack on a WEP access point, attempting to discover the key of the access point. We are not going to inject frames, so this is called a passive attack, which assumes that there will be some other activity going on in the network, so we can just listen. We will be using AeroDump-ng and AirCrack-ng for this. Let's begin by taking a look at our wireless configuration, which we see, well, we have WLAN 0 and WLAN 1. We don't actually need to use both of them. So let's say we use WLAN 0 and we run AeroDump on it. I have two windows open because I'm going to be running AirCrack in the bottom window. We don't need to finish gathering frames in order to start AirCrack-ng. So AeroDump-ng is going to be capturing frames, and then AirCrack-ng, once it has enough frames, will be able to recover the key. So we will run AeroDump-ng up here. One thing we will do first before capturing frames from the desired access point is to take a look at the different access points around, because we want to know the BSS ID of the desired access point. In this case, our ESS ID is test 1, so we can get the BSS ID, which is the MAC address of the access point, by copying from here. And we also get the channel number, which is channel 6. And we quit by just doing a Control-C. So now we can do a more targeted dumping for specifically BSS ID, and then we paste. And we also want to specify the channel. So that's channel 6. Last but not least, we want to specify a place where we can write the output file. So we pick test 1 as the name for the output file. So what it's going to do is it's going to be capturing all the traffic on this Wi-Fi network, test 1, and putting it into a file. So we see that it's capturing packets, and it's not very fast. It's getting a lot of beacons, but look at the number of data packets, not much. So this is going to take a very long time. Well, we can already start AirCrack-ng. Meanwhile, before we do that, let me just show you what has happened here. Previously, so it just created these files. Previously, they were not here. Now it has created these 4 files because I specified that the output file will be called test1. Notice that it added a -01 at the end of the name, so it's test1-01. The reason being that we don't want to overwrite something. If already there was a test1, we didn't want to overwrite it. So it will append 01, and then the next time it appends a 02, and so on. Also, the output comes in 4 different formats. So we have the cap file, which is what Wireshark uses, but also CSV, and then Kismet CSV and Kismet Net XML. These are 4 different formats that can be used, because for some purposes, you might want to use one or another. So then let's try running aircrack ng. And here we can optionally specify the BSS ID. We don't have to specify the BSS ID here because we have already done filtering in our capturing in AeroDump. So this is optional. But imagine if AeroDump was not filtering specifically for this BSS ID, we can filter at this point. So in that case, the capture file could be bigger, and we're just picking out those that are relevant to this BSS ID. So then we just need to specify the name of the file, which is test1-01.cap. And there we go. Aircrack ng is running. It says it failed because there were not enough IVs. You see that we only got, what, 400 something frames. It needs thousands of IVs in order to succeed. What it got here, we see that it got only 437 IVs because at that time the number of data frames was 437. And as it says up here, the attack will be restarted every 5,000 captured IVs. So Aircrack ng is smart about that. Even as test1-01.cap is being populated, it will wait and then it will continue with trying to find the key. And notice that it is using the PTW attack. This is the most efficient way to retrieve the key in the sense of needing the fewest IVs. Later we will see that if you use some of the earlier, older ways, you might need more IVs before you can get the key. So let's try to have more traffic in this network so the number of frames can increase at a higher rate. So we see that the key is found already because what happened was that I started doing some file transfers and the number of frames is much higher now, 70 something thousand. So looking back at what happened here, we see that it took, at first it got 437 IVs, that was not enough. Then at 5,000 it continued, and 10,000, see 10,000 IVs, that was still not enough. Kept waiting, and then 15,000 IVs, still not yet. 20,000, and so 20,000 and 29 IVs. At that point, it found the key, 41A19D05AA.